All right, Phil, are you ready to get started?
Yeah, sounds good.
Perfect. Okay, so I'll just give a little introduction here really quick, and then I will hand the reins over to Phil. So first and foremost, I just want to say hi. Welcome to our Lime versus Cement webinar, and thank you for joining us today. Phil is going to be teaching us the benefits of lime compared to cement and when lime may actually be the better product for your job or application. So for today, our host is none other than Mintek's resident expert, Mr. Phil Belcastro. He has over 12 years of experience in materials testing, including construction, environmental remediation, that's a mouthful, and soil stabilization technologies. He actually hails from our parent company, Carmuse Americas, and he has specialized in hands-on testing, method specifications, customer applications, and technologies associated with limestone, lime products, the whole gambit. So he has lots of experience to bestow upon us. Before I hand over the reins to Phil, I just want to make one quick kind of housekeeping note. So for those of you who requested to receive a PDH credit for attending today's session, you can expect to receive those by Friday. So keep a lookout for those certificates and they will be making it into your inbox. So with all of that, Phil, I will hand it over to you.
Yeah, maybe before I start, any questions, throw them in the chat box. I think some of my sales managers are out there too. Maybe we can answer them on the fly. If they don't, we want to discuss them later, we can do that at the end. So with that, yeah, we're going to be talking about lime versus Portland cement today. And let's start this off. I was talking to one of my sales managers and something that one of his customers really kind of just hung in my head. So I'm going to start with that. So he said they couldn't find any cement, so they had to do stabilization the old-fashioned way with lime. So maybe he was kind of using a primitive part of his brain, but I think maybe he was really thinking more like a genius. So speaking of old-fashioned, lime has been used for a long time. The Great Wall of China, for example, they used sticky rice mortar that was made of lime and rice flour to construct the wall. There's some ancient Chinese burial pyramids that were discovered about 5,000 years ago that were constructed with clay and lime, but who knows when they were really constructed. And yes, those other pyramids that you're probably thinking about in Egypt were also constructed with lime as well. The use of lime in subbases of the Roman roads dates back to more than 2,000 years ago, but that practice has probably been in that area for longer than that. So the use of lime in construction, specifically to improve soil, is nothing new. So if you've been on any of other webinars, you've heard me hammer home a couple terms: dry, modify, stabilize. That's what we do whenever our products are added to the soil. So they dry. We're going to improve the plasticity and other engineering properties like shrink swell potential with soil modification. And we're going to realize some permanent strength gains through soil stabilization. So back to the drying. Regardless of soil type, if your goal is to dry soil, lime is the way to go. The reaction absorbs a lot of water, over 30% of its weight in water as it hydrates as quicklime hydrates from calcium oxide to calcium hydroxide. We're going to draw that moisture from the soil. And the hydration process is a highly exothermic reaction. We're releasing an impressive amount of heat that drives off additional moisture in the form of steam through evaporation. And we'll see an example of that coming up here soon. But really, we can transform a wet, soggy, soupy mess of a site like this into something like this in really just a matter of hours. So I know we're only a couple minutes into this, so hopefully you guys aren't getting the urge to check your phone yet, so maybe we can get your fix here. We're going to check out a little short that we have out there on our YouTube page. So we kind of pared this one down for today. On the right, I had already added the same amount of water to cement, only about a 4-degree temperature rise. Then I went ahead and got my PPE on and took a step back as I added that water. You can see we got to boiling very quick, and 15 seconds later, went to give it a little stir for a little experiment here, and well, you can see what happened there. Not only did we absorb some water, but we absorbed all that water. Pretty impressive reaction there. So like I said, that's out there on our YouTube page. If you want to check that out for that and some more. And you can see the timer there. That took about 1 minute and 40 seconds. But really it was only about 15, 20 seconds of action with the quicklime there to absorb that water. So pretty impressive what it can do. Maybe a quick caveat there. In the field, we're obviously adding it in more of a controlled manner, so that's not what we're going to see. It was just a little experiment to show us what we can really see. So we talked drying. On the modification side, we're going to target that clay portion. We're going to positively alter the engineered properties of the weak, problematic, fine-grained soils. We're going to transform that soil through that treatment. So our chart here, we're going to modify the liquid limit and the plastic limit to decrease the gap between the two. That's what plasticity index is. It's the difference between the liquid limit and plastic limit. So our high oxide concentration in our products is going to dramatically reduce the plasticity of medium to high plasticity soils. So there is no rule of thumb of how much material to put in to reduce PI. You'll go crazy trying to correlate it. Believe me, we've tried in the lab. You really need that lab testing to determine exactly the benefit that you can see. And that's an example of what we're seeing here in this chart. We compared the performance of lime to Portland cement with a low, medium, and high plasticity soil. You can see that quicklime really dropped the gap the most. It was the best at modifying those troublesome soils with the high plasticity index. And then the green there, the low plasticity, there's not much difference between the two, but you figure, hey, we're already below 10 there. You can only really reduce that plasticity so much anyway. Those are probably already some pretty good soils as long as they're dry and around optimum moisture content. So we've talked about some of this stuff before in other webinars, but the benefits of modification really are, we're going to have easier compaction. We're going to reduce or eliminate that shrink swell potential and really give us a better overall working platform. We talked before about that OMC, that optimum moisture content. We're going to be able to shift that optimum moisture content point. We're going to drop it down, making it easier to hit compaction, less effort needed there. And also we're going to shift it to the right, meaning that we can have more moisture in the system at the time of compaction. It can be done at a higher moisture content. Going to reduce the drying need to hit that compaction. So dry, modify, on to stabilization real quick. So here at Mintek, me especially, I like to preach that we help you choose the right product for the project. So might have seen this chart before, play a little game in your head there. Think of where you think these lines might end up. I like to use the analogy of a sprinter versus marathon. The Portland cement is more of a sprinter. Strength gains kind of rapidly taper off. They get some good 7 and 28 days, but they tend to taper off, whereas the quicklime treated soils, as long as we have the necessary ingredients in there, our strength gains can continue. This study we did here at the Innovation Center was a 1-year study, and you can see that those strengths are still increasing over that time. So for the lime products, we're going to do that by either reacting with the natural pozzolans present in a soil, say the silicas and aluminas in clay soils with quicklime, or we can supplement those pozzolans with the calcement material. So it's also worth noting that it doesn't take 28 days to allow for construction operations to continue. Any engineers out there might be interested in the ultimate strength that can be realized. But for you contractors out there, know that we can get on that soil through the drying and modification much sooner than that. So really, what's that going to do for us? Those long-term results, better strength, rutting resistance, freeze-thaw durability. We're going to create a nice solid monolith that's not going to allow any moisture absorption and any shrinking and contracting that might come with those seasonal changes. Those lower dose rates, lime, you can allow for lower dosage rates to achieve those better long-term results. Another advantage that quicklime offers, and calcement for that, calcement as well, excuse me, is that it's not as time sensitive. So here's an example of a typical spec that's out there in a lot of the DOT books. Portland cement, it's got to be placed, mixed, and compacted within 3 hours, whereas the calcement, the quicklime, we have a day, if not more, really, to allow to get that compaction on there. The Portland cement side, not really allowing any time. If to correct if any equipment or other issues should happen. Portland cement is an engineered material. It's designed to give concrete finishers just enough time to complete their work, get the nice finish on their sidewalk or driveway out there, and then things are going to start to cure on you. And actually, gypsum is added to that cement mix and concrete to delay that set time. Whereas the Mintek products, we allow for construction life to happen. Maybe equipment breaks down or something like that. It just gives you a little more flexibility that way. Before I hop on to the extended working season, I should note that another nice advantage to it is if you're working with any spoils, trenching, any cut material that you're setting off to the side, if that's been mixed with lime, you can get a little light compaction on it, set aside and use as a nice engineered fill material for later. So we talked about heat generation. So we can actually use that heat generation to drive reactions and generate heat. And this is a nice little tip that we've talked about before on other sessions, that we can actually even kickstart Portland cement with just maybe a percent or two, probably really like just a percent of quicklime. And that heat that will be generated is capable of driving those desired chemical reactions, even in the frozen soils. So my first shameless plug is check out another one of our resources on our website, our cold weather liming cut sheet, for more tips as we move through fall here into the winter months to keep your project moving. All right, so today's reality. The reality is that Portland cement consumption is outpacing production. So a number of factors have gone into that. We had that thing called COVID happen, which put all sorts of projects on delay. There's been some funding out there that I'm sure all of us are aware of. And once things loosened up, we had that project boom that happened. So really a number of factors went into that, but the consumption is outpacing production. In the winter, cement applications like concrete slow, allowing inventory of cement to grow. So we may see that cement availability loosen up here in Q1 coming up in 2023. But it's likely that those inventories aren't going to get back to where maybe we like to see them for the cement availability side. But it's likely that those supplies will ultimately run low again, resulting in more allocations. Leaving silos and other storage looking something like this. Some numbers that I found while putting this together was that the U.S. Portland cement production was pretty consistent over the last couple of years, around 95 million tons per year, whereas the U.S. Consumption over the last 20 years is more like 120. So had a bit of a difference there. We've done our best to kind of make some efforts to close the gap, including importing cement. So maybe I challenge you out there to look domestically here at home for a product that's produced here in the U.S. with supply to meet your demand. You can see on the right, that's a picture of the Carmuse network. Like Kendall said, I'm based here out of the Carmuse Innovation Center. Here's a kind of a quick map of all the locations, but rest assured that any of the folks I've talked to out there, I'm 100% Mintek support, so reach out to me anytime you've got any questions regarding Mintek. Another shameless plug, speaking of storage, we do have bulk storage available where we offer pig rentals as one of our resources. So with that, we've seen many projects not only consider, but successfully switch from lime to cement. With everything being as tight as it is, people are starting to realize that maybe the old-fashioned thinking of just the easy button, throw some cement in there, make it hard. It could work if it's available, but there's an alternative out there, and that's what we're talking about today. However, neither lime nor Portland cement is a silver bullet. Cement's not going to be perfect for everything out there, and neither is lime. So whenever change orders happen or forecasting shifts, it's likely that nowadays the availability of cement probably isn't going to be there. And the remove and replace option just isn't cost effective. We've talked about that in previous sessions. And if you haven't attended those, feel free to reach out. We can discuss that. So I've said it before, say it again. We'd like to preach the right project for the right project. We've got a nice tool out there. It might look a little different to anyone who's familiar with it. Gave it a little bit of a facelift, but our chemical stabilization selection guide is a great tool for project managers and estimators to have with them. Give us a call if you want. We've got a nice little laminated one you can send your way to have in your binder out there on the field, or you can pull it from our resources page online. What we did here, we went from granular soil like sand to high plasticity, high clay soils on the right. So regardless of what you're trying to do, that green bar on the bottom says it all. Well, not regardless. If you're looking to simply dry soil, regardless of the soil type, the green bar at the bottom says it all, that the lime products are the way to go. They're going to be great at getting rid of that water for you. Portland cement works very well on the granular sandy soils, but as you get into the fat clay soils with high plasticity, the quicklime really does a great job of breaking through that and decreasing the plasticity and making that a much more workable soil. And then the cow cement kind of bridging the gap in between. It has the available oxide content just like quicklime. However, we do have some pozzolans in there that can kind of supplement to give us some strength. And another thing I like to point out when I'm usually talking about this tool is at Mintek, we're not going to try to push you in the wrong direction. Feel free to reach out. Hey, we have these type of soils. What do you think? We're not trying to set anyone up for failure by pushing lime on a soil that's just not going to work. When we've done some studies with this, there's been at least one or two that the lime, it just didn't work for us. And we were straight up with who we were talking to there, that we had to look and consider other options. So we don't want to set either your company or our company up for failure. But really the lime conducive soils, general rule of thumb we have in our head, clay content of 25% or more is a good threshold, and also plasticity of 10 or more. And with that, the switch is on. So we're going to go through some data that we've seen here in our area, and general rule of thumb as well, as far as target strength, about 125 psi is generally acceptable. So I'm going to have some charts pop up here, and we'll see how these results compare to that. So I threw some pins in the map where we've seen success, and if you'd like to see what your soils can do, we'll talk about that a little bit later, but keep us in mind. So first, I wanted to start with a very good result showing just how reactive lime and soil can be. This was down in South Carolina, where we had actually a PEI of 53, so pretty high up on the plasticity there, and high clay content, 45%, so a reactive soil. But really, that was a very undesirable soil to have on site. And you can see an impressive strength that was realized with just 4% quicklime. So we had that undesirable soil, and we transformed it to a nice engineered fill material with impressive strength. So moving on, we're seeing many projects not only in major metros, but also in rural areas. In the Columbus, Ohio area, that area is building for sure. We've been out there with Tim, our sales manager in that area, a lot. Facebook's, Amazon's, etc. We're seeing a lot of those folks specifying lime treatment right up front, have it in the books to make sure it's available. There we're seeing some really impressive CBR gains of 10-fold there. So pretty impressive. Cambridge, Ohio, just east of Columbus there, right on 70. We stabilized that soil with over 250 PSI, but also had the added benefit of soil modification. The crews didn't have to dry that soil back as much to hit that optimum mark. You can see that in the table there in the middle of the screen. In Virginia, a lot of success there with some soils as well. Alti just outside Richmond, and also enrichment itself, but both unconfined compressive strength charts there show that the lime products, specifically quicklime, could be considered as an alternative to Portland cement. Now this data, before Jim, my sales manager from that region, comes through the screen at me, this data is from a study where we looked at soils across our region and we compared them with all of our lime products. So with that, the cow cement availability in Jim's region, I know, is tight to non-existent. So keep that in mind, but just showing that what is possible with these lime products. In Gainesville, just west of DC, this developer was not only looking to increase the unconfined compressive strength and the CBR, but he also wanted to mitigate swell as well. So we benefited from that soil modification, not just stabilization to get the strength. We mitigated that swell potential, taking it from a medium threat to a very low threat of expansion. Did that testing here at the Innovation Center with an ASTM test. So it's pretty good to see those results. So soil stabilization with the unconfined compressive strength, but also the expansion mitigation as well. Moving on to Chicago, cement is definitely tight in Chicago. I know that Norm's guys are struggling to find it, and we're moving on with success. And we've had a lot just recently. Number of projects have come through in his area. Here's an example in Romeoville, Illinois, just outside of Chicago. This customer, I'm not sure if you're on, but hey, he's been using quicklime here for some time now. And here we are confidently hitting our 150 PSI mark at 7 days, but really we were close to the 200 mark and growing with time. Also, once again, benefited from soil modification. You can see the untreated optimum moisture content at 13.5. So he had to dry that soil back to that almost 14% mark. If we didn't throw anything in it, cement increased that a bit to 15-ish, but the lime products almost 17, a little over 18. So we didn't have to dry it back as much to hit that target mark. And some of those pictures might look familiar as well. We've used those before when we talk cold weather liming. Some of the in that middle picture, what you're seeing is actually a lot of steam, not necessarily dust. It was a cold day outside Chicago. We were able to keep the project moving on that cold day, realizing that temperature gain to thaw those frozen soils. Staying in Norm's area, in Northwest Indy, this soil is a little bit interesting because we dropped below the 25% clay threshold that we like to use, and with good results. Also worth noting is that you don't see any other cements or any other materials mentioned down there, because here we had no choice. We were going to use quicklime. Let's see what we can get. However, working with the customer, the timing of everything, our traditional 7 days break, it just wasn't going to work. So another resource here with Mintek is the Innovation Center. So my soil lab just outside my window, we're developing what we're calling a rapid cure or accelerated cure test. So I was able to relay some results after only 48 hours, and then we later confirmed them with the 7-day mark. So we felt very confident going back to the customer saying, hey, we're going to get some great results here. They're going to continue with time. Feel good about putting down our lime here and move on with your project. And we went back to him later and confirmed what it was going to be. North Indy, both lime products outperformed Portland cement here with great gains over that weak in situ soil. So switches on in North Carolina as well. Huntersville, just outside of Charlotte. Linwood, between Charlotte and Greensboro. You're seeing a bit of a trend here. So that big green bar is a good indication of how things are going, especially there in Huntersville, but the others as well. So cement could have got some great results, but here the quicklime outperformed it each time. Like I said, our trend is continuing in Tennessee, the Nashville area. Really traditionally thought to be for cement only, but we've been testing and seeing some soils where lime should not only be given a chance, but really might be the way to go. Trend is continuing here. We had a same same soil project we were working on here. We blended soil from a couple of different regions in Georgia, and sure you can see that the cement and quicklime bars are right next to each other, but if we can't get that cement, you can see that the quicklime is a not only great alternative, but keep in mind how those strength gains can continue over time. So with that, I want to just kind of wrap up this rather short webinar by saying, get us involved early. The testing takes time. I mentioned the 7-day cure before. It takes time to get things in our queue, process the soil, get it mixed, get it tested, and let those samples cure. But we can work with all involved as a resource. Talk about how Mintek Resources really is that. It's a resource for more than just the material. To the engineers out there on the call, advising and specifying on those projects, we do lunch and learn sessions with PDHs, similar to what we're talking about here. And we're able to talk about anything lime you're interested in. So please reach out to the labs, those geotechs out there performing the tests. Mintek can come out to your lab, teach a review to help you help your customers. It's worth noting that here at the Innovation Center, me and my guys, we'd like to prove out the products, but we're definitely not set up for production. Those other labs out there that can bang out a number of soil samples, a number of different projects, way to go, but we can definitely help prove out the products. The stabilization contractors out there who help to show those results in the field, Mintek offers on-site support. And the general contractors out there who need to show those results to the site developers who are actually paying the bills, we can help to relay those results. We've been working on some projects. We're just trying to educate and let people know what's possible with lime, and we've put reports together that they can then relay to the other parties involved. So I kind of want to wrap things up by reminding you that as we move into these wet, cold months, if you're simply looking to dry soil, we're faster than cement at doing that, hands down. No matter the soil type, the lime products are going to be what's good for you. Once again, we absorb over 30% of our weight in water as it hydrates, drawing that moisture from the soil, producing a lot of heat that's going to drive off additional moisture and even help to kickstart cement in some instances. So with that, I'm going to hammer it home one more time. Whenever we add our lime products to soil, we're going to dry, modify, and stabilize. Last shameless plugs here. Once again, reach out to us if you need some storage needs. Check out additional cut sheets on our website. I've mentioned our YouTube channel before. We've got some, I think, kind of cool videos out there and more coming. And a huge resource is just our website in general. So, definitely check it out. Check out the resources tab there. See what sort of applications, products, things like that we have to offer, or just reach out to any of your Mintek's contacts directly. Yeah, so with that, I thought about a half hour in here. So we'll open up to Q&A. I think we might have some of our sales guys on. I see the Q&A bubble up there. We might have had a couple come in. So I'll be quiet for a moment, maybe read over that. And Kendall, if you could help me maybe make sure some of the sales guys could talk, and we'll start to relay any questions that might come through. All right, Michael, what happens to lime-treated soils after it rains or gets wet again? So we always preach to get some compaction on there and some grading to shed that free water. If you do that, things are going to hold up very well. But it is still soil. If you leave it uncovered over the winter months, you can't expect your lime-treated soil to just hold up just like that. So one of our tips would be not only to compact it and get some grading on it, or grade the material to shed some water, but also throw some stone on there to protect as well, especially if you've got machinery running over it. So I'll be quiet for a moment again to see if any my sales guys might want to add anything to that. If not, I'll read the next one here. So Michael had another one. Any issues treating soils within a reinforced zone of a retaining wall, specifically regarding damaging or affecting long-term strength due to its pH? Are there any studies available? I don't know if there's studies available. I know I did look into pH of some geogrids before, and we'd have to consult kind of the manufacturer of those products to see what pH they're rated for. I know if you go cheap, I think I want to remember that there was at least one of the products that couldn't hold up to the elevated pH associated with lime, which is 12.45. But I also think that whenever I was going down that alley with that customer, that there were some kind of thicker, more robust products out there that did hold up to the pH. So a little bit of both. Michael, I'll try to get back to you if I can find anything more on that. Norm, Rusty, I think that was one of Jim, was that a question that came from one of your guys about a year ago or so? I can't remember for sure. So I'll be quiet for a moment while I read the next one to see if anyone has any more comments associated with, I think, really pH and kind of other materials. No, we've had a couple conversations about iron pipe, PVC, things like that. That stuff holds up to the pH of lime as well. I've never seen any utilities or anything like that have problems with lime treated soil. That was just another thought I had about Michael's last comment there. Oh, thanks for attending, anonymous attendee. No, I'm kidding. All right, so you may have mentioned it, but what are the curing times for the comparison versus for UCS testing? So good question. I didn't throw them up on the chart just to kind of try to keep things clean, and I didn't mean to mention it, so thanks for bringing it up. Our standard cures in the lab that I've compared here for the lime products, we do 7 days at 40 degrees C as our standard. So it's kind of an accelerated cure, if you will. And then we compare that to 7-day ambient cement. So we found that cement is essentially the same at 28 days, and the 7-day accelerated 40-degree cure for the lime products correlates roughly to a 28-day ambient. So I think I answered your question. For the lime products, 7 days at 40 degrees C, except for that accelerated one we mentioned. We tweak things a little bit, and then 7-day ambient for cement. Anonymous had another question. When you're drying with quicklime, do you need a mellow period? Yeah, it's a good question about mellow period. Drying, not necessarily. Usually we have ample supply of water around to be sure that things are properly hydrated. The mellow period, also with drying, typically our dosage rates are 1 to 3%, so relatively low. Really not much risk of any sort of post-compaction heat, because like I said, usually there's plenty of water around to properly hydrate the material. Where we start to talk about mellow period a lot is on the modification and stabilization side. We might be throwing down more material, 2, maybe 3 to 5%, maybe upwards of 6, kind of where we usually top out, rarely, usually 4 to 5%. But it is important that we properly hydrate all of our quicklime. And to do that, we do recommend a 4-hour mellow period. In the lab, we actually do a 24-hour mellow just to make sure that things are completely hydrated here in the lab, those controlled lab conditions. But in the field, we recommend 4 hours. And usually our guys out there that have worked with this, they know how to kind of work in one area and kind of progress through and then come back, maybe even get a second mix to churn up any unhydrated pieces, get the final mix in there to make sure you're using all the product that you're putting in the ground. Let's see. What's the rule of thumb when quantifying the amount of lime needed? That's kind of one of those ones where I said you'll hit your head against the wall trying to figure out, a real tight correlation. Hey, my soil type is this, it's this moisture content. How much lime do I need? Hard to say. Drying applications, 1 to 3% is a good range. when you're trying to modify, you're trying to drop an A7 soil to an A4 or something like that, to 3% to 5%, and stabilization maybe just a little higher, 6% usually topping it off. Stabilization modification, it's important to do lab testing to be sure that we know exactly, we can realize the result, we can get the expected result. Another good tool we have that might be worth mentioning though is the dose rate calculator that does a good job, but definitely reach out to us to kind of walk through it. But it's a nice little tool that we do have on our website. You can plug in some things to get a general idea. And if you know your square footage and the dose rate you need, we can tell you how much lime you'll need. But it's kind of very basic. There's probably more questions that the sales guys and myself and some others will probably ask you. But dose rate calculator is a good one to consult there. So Adam, I hope I answered your question at least a little bit. Okay, the expansion index, specifically what determines low risk versus medium risk. It was it's an ASTM method that we used, and there is a range, and I can't think of the word, but there's no value to it. It's a ratio more or less with the expansion, and there is a chart associated with that ASTM test that I can get back to you. However, we did do that one. It was requested by the customer. We found that we like to use just CBRs. We think it's a bigger sample. We're getting a CBR number with it, but we'll put a gauge on the CBR as it's soaking to see how much it expands. So really, we did the ASTM method there, but we like to use a swell percent that we can do whenever we run a CBR. So, and that also is 7-day test, but we also do, on top of that, we do a cure time. So I'd have to get back to you to recall the total time for that. But that expansion index is an ASTM test that I can get back to you. If you want to reach out, since you are coming up as anonymous, we can get back to you and I can reach out and talk about it a little more. It's a good question coming from Michael again. Can lime be used to eliminate frost in the ground after it's already present? If so, what depth could it be done? Or what would require the contractor break up the frost and then add lime and water? Yeah, it's a great one. So we're kind of getting into our cold weather liming tips, but lime will react with water, but it's got to be, it has to be in a liquid form. So you could maybe go on there, spread some lime and the reclaimer, mix it up and generate some heat to get things going. But one of our tips is to kickstart the lime with some water to get that hydration reaction going, start to generate that heat that would then thaw your frozen ground. There's some limitations, really how cold is it? How thick are things frozen? So if you're kind of borderline on the frozen, you're dipping down in those frozen areas, maybe the sun's out during the day and it's nicer, but in the morning things freeze to, just on the surface, maybe a couple inches or so. That's definitely something we can work through. But if we've got a solid foot of, frozen ground or permafrost, we're not gonna be able to do that. But those reclaimers that are working out there do a nice job of breaking through that. But that would be my tip. It would be to kickstart with a little bit of water to start to generate that heat. So hope you answered that question as well. So that's the last question we got in there in the queue right now. Feel free to give some more. I'll be quiet for another moment. If any of the guys want to elaborate on anything I said, that'd be fine. So I'll give that a minute while I take some water. All right, well, it looks like we've got no more open questions. I guess my final remark would be, thanks for joining us. We always like to help you save time, save money, improve your subgrades, and get you that nice engineered fill that will outlast your project. So with that, thank you, and we'll see you next time.